And now in this lecture we find out the area of square ABCD. In the moment we have square ABCD. You know that DB is the diagonal of square ABCD. This is again BDP is equals to 30 degrees inside. This is again PBC is also equals to 30 degrees inside. Side line segment PB equals to 5 units in each length. Again, our test is to find out the area of this square ABCD. So first of all, we know that the diagonal of a square bisects the angles of the square. This is diagonal DB, it bisects this angle, this angle ABC. So diagonal DB bisects this angle, so this angle will be equal to 90 degrees over 2, that is 45 degrees. And this angle must be also equal to 45 degrees in size. But this angle equals to 30 degrees. Therefore, this missing angle must be equal to 15 degrees in size. In order to complete the size of this angle to 45 degrees, this missing angle must be equal to 15 degrees in size. Likewise, diagonal BD bisects angle ADC of square ABCD. Therefore, this angle must be equal to 45 degrees in size. Likewise, this angle must be also equal to 45 degrees in size. This angle equals to 30 degrees, and therefore this missing angle must be equal to 15 degrees in size in order to complete the size of this angle to 45 degrees. So, in triangle DBP, this triangle, we have this angle is equal to 30 degrees, this angle equals to 15 degrees, 30 degrees plus 15 degrees is 45 degrees, and therefore this third missing angle must be equal to 135 degrees in the side. Again, the missing angle here must be equal to 135 degrees in the side, according to the rule that the sum of the angles in the angle is equal to 180 degrees. In the next step, we will draw a circle around this square ABCD in such a way that point A will be the center of the circle, and here we define AB as X. One side of square ABCD equals to X units in its length, therefore AD must be also equal to X. So again, we will draw a circle around square ABCD in such a way that point A will be the center of the circle, and the radius of the circle will be equal to X, that is the side length of square ABCD. Okay. So actually, this is the circle that we draw around square ABCD. So I mentioned point A is the vertex A of square ABCD is the center of the circle, and the radius of the circle equals to X. That is the side length of square ABCD. So AB equals to X, the radius of AD also equals to X, and it is also the side length of square ABCD. So here we have we know that the sum of the angles around any point is equal to 360 degrees. So the sum of the angles around point A must be equal to 360 degrees. This is a right angle. It is one angle of square ABCD that equals to 90 degrees. Therefore, this missing angle must be equal to 270 degrees in its size. So actually, angle DAB, the big angle DAB, that is a central angle, it is equal to 270 degrees in its size. This is angle DPB, that is equal to 135 degrees in its size. Angle DAB, central angle DAB, subtend on chord DB. Likewise, angle DPB also subtend on chord DB. So those two angles are both subtend on chord DB. Here we can implement rule 13. According to rule 13, the central angle is twice as large as the peripheral angle subtended on the same chord. In the following area circle, this is peripheral angle ACB that subtend on chord AB. Likewise, we have this is peripheral angle ACB that subtend on chord AB. This is central angle AOB that is also subtend on the same chord called AB. And according to this rule 13, central angle AOB must be twice as large as this peripheral angle ACB that subtend on the same chord called AB. Peripheral angle ACB equal to theta, therefore central angle AOB must be equal to 2 theta. So a central angle is twice as large as the peripheral angle that subtend on the same chord. So you can implement rule 13 in our drawing. Because in our drawing we have central angle DAB that subtend on chord DB and is equal to 270 degrees. And we have angle DPB that subtend on the same chord called DB, and it is equal to 135 degrees in its size. So angle DPB, angle BAD, central angle DAB is twice as large as angle DPB, because 135 degrees times 2 is 270 degrees. And because of the fact that angle DPB subtend on chord DB exactly like central angle DAB, it must be a peripheral angle, because it is half of the size of the central angle. And because of the fact that angle DPB is a central angle, angle DPB is a peripheral angle, according to rule 13, point P must be on the circle itself. Point P is the vertex of peripheral angle DPB, and therefore it must lie on the circle itself. Okay, so actually found out that actually it didn't knew that DPB is a peripheral angle, but because of the fact that angle DPB equals to 125 degrees in size, and it's subtend on the same chord called DB, on the same chord called DB, exactly like central angle BAD, and it is half of the size of central angle DAB, this equals to 270 degrees. Therefore, according to rule 15, angle DPB must be a peripheral angle because it is half of the central angle BAD that subtend on the same chord called BD. And therefore, angle DPB is a peripheral angle, and therefore point P, vertex P, must lie on the circle itself because it is a peripheral angle, and therefore vertex P of peripheral angle DPB must lie on the circle itself. So in the next step, we join points P and A together by a straight line. Point A is the center of the circle, point P is the point of the circle itself, therefore AP is the radius of the circle that is equal to X. So in the next step, copy triangle ABP. In a new page, we'll analyze this triangle ABP. This is angle ABP. Angle ABP in total equals to 45 degrees plus 15 degrees, that is 60 degrees. Here we are talking on triangle ABP. So copy this triangle ABP in a equation. We analyze this triangle ABP. Again, this is angle ABP. The big angle is angle ABP. This is equal to 45 degrees plus 15 degrees is 60 degrees. So this is triangle ABP, that is coming from the original drawing. So I mentioned before, this is again ABP, this is equals to 45 degrees plus 15 degrees is 60 degrees. AP and AB, they are both the area of the circle. That is equals to X. So triangle ABP, in front of those two equal sides, we have those two angles that must be also equal to each other in the sizes according to the rule that in front of equal sides in the triangle there are equal angles. But this angle equals to 60 degrees and therefore this angle must be also equal to 60 degrees in its size according to the rule that I mentioned. So in triangle ABP, 60 degrees plus 60 degrees is 120 degrees and therefore this third missing angle must be equal to 60 degrees in its size, according to the rule that says that the sum of the angles in any triangle is equal to 180 degrees. So, triangle ABP is an equilateral triangle. Triangle ABP is an equilateral triangle. And know that all the sides of any equilateral triangle are equal to each other. That is to say BP equals to BA equals to AP. So BP equals to BA equals to AP. BP equals to 5 according to what is given as the question. And for this equation, we derive that 5 equals to BP equals to BA equals to AP. We derive that BA equals to 5. BA equals to 5. BA is x equals to 5. AP also equals to 5. BA is one side of square ABCD. So one side of square ABCD equals to 5 units in itself. And we know that the area of square ABCD is equal to the length of one side squared. So it is BA squared. BA is 5, therefore BA squared is 5 squared, that is 25. So if you know that this square ABCD is equal to 25 square units in size. So in the next step, aside the lecture, our task in this lecture is to find out the area of this square ABCD. So in the following year square ABCD, it is given us a question that PB equals to 5 units in its length. We know that this is again PBC is equals to 30 degrees in its size. This is again PDB. This is also equals to 30 degrees in its size. Again, our task is to find out the area of this square ABCD. DB is the diagonal of the square, and we know that the diagonal of the square bisects the angles of the square. Again, the diagonal of the square, the diagonals of the square bisect the angles of the square. So diagonal DB bisects the angle ABC. So this angle equals to 30 degrees. This angle must be also equal to this angle must be equal to 15 degrees. Why? Because 15 degrees plus 30 degrees is 45 degrees. That is one half of the big angle ABC. Likewise, the second half of angle ABC is 45 degrees. Likewise, the diagonal BD bisects angle ADC. So therefore, this angle must be equal to 45 degrees in size, and this angle must be also equal to 45 degrees in size. But this angle equals to 30 degrees, and therefore the missing angle must be equal to 15 degrees in size in order to complete the big angle to 45 degrees. 30 degrees plus 15 degrees is 45 degrees. So, in triangle BDP, this angle equals to 15 degrees, this angle equals to 30 degrees, 15 degrees plus 30 degrees is 45 degrees, and therefore this missing angle must be equal to 135 degrees in its size, according to the rule that says that the sum of the angles in any triangle is equal to 180 degrees. In the next step, we define one side of square ABCD as x. So AD equals to x, AB equals to x, on the other side must be also equal to x units in its length. Their lengths. So in the next step, we did the construction, that is to say, we draw a circle around square ABCD in such a way that point A will be the center of the circle that we will draw, and AB is equal to x will be the radius of the circle. And again, we draw a circle around this square ABCD in such a way that point A is the center of the circle, and x is the radius of the circle. X is also the side length of square ABCD. So here, this is the this is the circle that we draw around square ABCD. As I mentioned before, point vertex A of square ABCD is the center of the circle, and X is the radius. AB is the radius X, AD is also the radius X. Actually, points B and D must pass for the circle itself. Again, points B and D, that are the vertices of square ABCD, must pass for the circle itself. So here we only found out that angle BPD equals to 135 degrees in its size. Here we focus on point A. We know that the sum of the angles around any point is equal to 360 degrees. So which angles we have around point A? We have this as a right angle, plus this missing angle must be equal to 360 degrees according to the rule that I mentioned. Therefore, the big missing angle must be equal to 270 degrees in its size. So this is peripheral angle, this is center angle BAD, that subtend or called DB. Again, center angle BAD, subtend or called DB. We have angle DPB, also subtend on the same chord called DB. And we have the rule that, according to 13, the central angle is twice as long as the peripheral angle subtended on the same chord. So this is central angle DAB. This is equal to 270 degrees in its size. This is angle DPB. This is half of this angle. This is 135 degrees. So actually, angle DPB obeys to rule 13. And because of the fact that angle DPB obeys to rule 13, that I read, it must be a peripheral angle. You can see here that central angle DAB subtend on chord DB, and it is equal to 270 degrees. Here we have peripheral angle DPB that subtend on the same chord called DB, and therefore it is equal to 270 degrees over 2, that is 135 degrees. And because of the fact that angle DPB obeys to rule 13, it must be a peripheral angle. So DPB is a peripheral angle, and therefore point P must lie on the circle itself. Because of the fact that angle DPB is a peripheral angle, the vertex P must lie on the circle itself. Okay. So in the next step, we join points A and P together by set time. Point A is the center of the circle, point P is the point on the circle itself. Therefore, AP is the radius of the circle, is equals to X, according to our definition. In the next step, we copy triangle ABP. This is triangle ABP. Then I copy to a new page and we analyze this triangle ABP. This is angle ABP. Angle ABP in total equals to 45 degrees plus 15 degrees, that is 60 degrees. So okay, this is triangle ABP. Then I copy from the original drawing. So as I mentioned before, this angle equals to 60 degrees in its size. Those two sides are both equal to X, and we have the rule that in front of equal sides in the triangle are equal angles. So in front of those two equal sides, we have those two angles that must be also equal to each other and their sizes. But this angle equals to 60 degrees, and therefore this missing angle must be also equal to 60 degrees in size according to the rule that I mentioned. So in triangle ABP, 60 degrees plus 60 degrees is 120 degrees. And therefore this missing angle must be equal to 60 degrees in size according to the rule that states that the sum of the angles in any triangle is equal to 180 degrees. So triangle ABP is an equilateral triangle because all of its angles are equal to 60 degrees. So the equilateral triangle AVP, we know that all the sides of any equilateral triangle are equal to each other. So AB equals to BP equals to AP. But BP is 5, according to what is Gauss equation. Therefore, AB must be also equal to 5 units in its length. AB is one side of square ABCD. Now the task is to find out of this square ABCD. We know that the area of any square equals to the length of one side squared. And therefore, the area of square ABCD must be equal to the length of one side squared. That is BA squared. BA is 5, therefore BA squared is 5 squared, that is 25. So in total, we shall know that the area of this square ABCD is equal to 25 square inches in size. Okay, thank you very much.